All right, you guys, section 4.2 for pre-calc. First thing we need to do is just give you some definitions. Certainly you guys have seen before SOHCAHTOA. Oops. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So opposite over adjacent. And these are the co-functions that go with them, and they're the reciprocals. H over. So the hypotenuse over. Oh my goodness. And secant is going to be hypotenuse over adjacent. And cotangent is going to be adjacent over opposite. Now, there are other definitions of this to go with it, and sine of theta is going to be 1 over the cosecant of theta. Cosecant of theta is equal to 1 over the sine of theta. These are reciprocals of each other, so these are reciprocals of each other. Okay? Secant is the reciprocal of cosine. Cosine is the reciprocal of secant. It would be wonderful if cosecant would with cosine, but they don't. Secant is with cosine. Cosecant is with sine. And please don't pronounce it CSC or SEC or TAN. Say the word. Sine, cosecant, cosine, secant, tangent, and cotangents down off the bottom of the page there. Off the screen. Okay, now on the unit circle, the connection is, so if I want it of 30 degrees, which is right here, the coordinate at 30 degrees, this distance up is your y value, this distance over is your x value. And this is your hypotenuse, which is worth 1. Standing here at 30 degrees, sine is your opposite side over your hypotenuse. So you might as well just say your y value. Cosine is your adjacent over your hypotenuse. So you might as well just say your x. Likewise, those are the reciprocal. Okay? Tangent is your opposite over adjacent. So it's your y over your x, and this would be your x over your y. Okay? I personally don't spend the time, if someone asked me the secant of 30 degrees, what I would do is I would find the cosine of 30 degrees, which cosine is your x, 30 degrees, the coordinate is square root of 3 over 2, a half. So the cosine of 30 degrees is square root of 3 over 2. So the secant is 2 over the square root of 3. And you rationalize it. Square root of 3. So it becomes 2 square roots of 3 over 3 would be the secant of 30. I don't go straight to doing 1 over x. It doesn't work for me. If you guys find that that's helpful, by all means, go for it. I find it's helpful to find the original function and just take the reciprocal of it. Okay? That's what works for me. Oops, this picture is a little bit off the screen because there's a 3. All right. If you're standing on a right triangle, sine opposite over hypotenuse, the sine of that angle, so the sine of this theta, whatever theta is 3a's. Here, you're using the same idea. Opposite, hypotenuse, adjacent, hypotenuse, and so on. So you just, when you're on the unit circle, you're just either going to read the x or the y. Right? Now, for the tangent, you're going to read them both up. Okay? So if I say, give me the tangent of 30 degrees, 30 degrees is here. It's your y value over your x value. So that's a half is being divided by the square root of 3 over 2, which becomes a half times 2 over the square root of 3. Those cancel. So you get the tangent of 30 is 1 over the square root of 3. And then you rationalize it. And you get the tangent of 30 is equal to square root of 3 over 3. Okay? So you're going to use the unit circle to get those 6 trig functions. Okay? Keep in mind, these definitions are only true if your hypotenuse is worth 1. So when we start getting off the unit circle, that isn't going to be true anymore. Okay, I'll give you some examples later on. One of the things you guys have to do today is know the unit circle in radians. The coordinates are exactly the same. So what's additional today is memorizing it in radians. The first angle is 0. Second one is pi over 6. And pi over 4. 3. 2. Now, slowing down, looking at this is 30 degrees. 30 degrees is here. 60 degrees is there. Isn't 60 double 30? So if this is 30, and I double it, you get pi over 3. Okay? 60 degrees is here. That's 160. Double it. You're standing at 120. So that's going to be 2 pi over 3. Add another 60 degrees. You're at 3 pi over 3. So you're right here at pi. Add another to this one, pi over 3. Another 60 degrees is right here. So that's going to give you 4 pi over 3. Add another 60 degrees, and you're here. So that's going to be 5 pi over 3. Okay? 6 pi over 3 brings you right back to the beginning at 2 pi. All right, let's try 45 degrees. 1 45s, 2 45s, so 2 pi over 4 reduces to pi over 2. Add another 45 and you get 3 pi over 4. That's a 4. Let me get it off of there so no confusion here. Add another 45 degrees and you're at 4 pi over 4, which once again is pi. Add another pi over 4 and you're at 5 pi over 4. Add another 45 and you're going to be at 6 pi over 4. I hate those 4s. 6 pi over 4, which is going to be 3 pi over 2. So this is 3 pi over 2. 6 pi over 4, add another pi over 4, and you're at 7 pi over 4. Okay? Go to the 30s. 1 pi over 6, double it, 2 pi over 6, triple it, 3 pi over 6, quadruple it, 4 pi over 6, 5 pi over 6. This is going to be 6 pi over 6. And notice, this is 1 pi over 6 less than 6 pi over 6. Okay? 6 pi over 6, one more is 7. Another one makes 8, 9, 10, and 11 pi over 6. Go one more and you're at 12 pi over 6. That's going to reduce to 2 pi, but notice if you could back one off of 12, you're sitting at 11. Okay? Notice that everything that's on these boxes, if you go with these diagonals around, not diagonals, these, yes, these things, all the denominators are the same. Yikes. Getting carried away here. Okay, bam. Come on up. All of these denominators are the same. They're the same angles. And they should have the same coordinates. You're just going to change signs. Okay? So that's the unit circle in radians. If you have further questions on how to memorize it, strategies for marching around it, let me know. I'll be happy to walk you through it. This is expected for you guys to memorize. If you have questions, like I said, let me know. Some more terminology, coterminal angles. This is your initial side. Initial side, and this would be your terminal, your ending side. Okay, initial side, terminal side. It's opening this. It's opening up. Okay, so coterminal angles are angles that end on the same side. Okay, so alpha is being measured here, is coterminal with this angle here. They're ending on the same side. Alpha and beta are coterminal angles in this picture. They're ending at the same place. They have the same initial side. They're both starting at the same place, and they have the same terminal side. So they're coterminal angles. Evaluating a trig function using the period as an aid. Okay, period is how often a sucker repeats. Okay, every 360 degrees, your answers will start to repeat. Every full circle they repeat, and 360 is the same as 2 pi. So they're going to repeat. This one's in radians. 2 pi is a full circle. It's all the way around. Dealing with thirds, that'd be 6 pi over 3 is a full circle. It's all the way around. So this could be thought of as the sine of 6 pi over 3 plus 1 pi over 3. So in the picture, what's going on is you're starting here, you're going to go a full circle, and then pi over 3 more. So you're going to end right here. So it's saying, hey, what's that angle? Well, that angle's the same as pi over 3. You're at the same location as pi over 3. So in effect, this can be disregarded because you've done a full circle and landed at the same location. The example here was 45 and 405. 45 plus, whoops, yikes. 360 equals 405 degrees. Okay, so starting here, pull a full 360 and then go 45 more. You're sitting at the same location as plain old 45 degrees. So, since sine of an angle, if you're on the unit circle, is your y value, it's the same location. These have the same y value. So then the sine of pi over 3. So thinking about pi over 3, sine is your y value, so that's going to be square root of 3 over 2. I'm dealing with force. 8 pi over 4 is equal to 2 pi. So 11 pi over 4 is 8 pi over 4, a full circle, plus 3 pi over 4. Why did both of those close? It's so frustrating to me. Okay. Because it's a full circle, I can disregard it. So I'm asking, what is the cosine of 3 pi over 4? Cosine is your x value. Your x value at 3 pi over 4, which is right there, is negative square root of 2 over 2. Okay, cosine of 450, that's 360 plus 90. So that's the same as the tangent of 90 degrees. Same answer. Tangent is your y over your x. Your y value at 90 degrees, right up here. The coordinate is 0, 1, so it's 1 over 0. So the tangent of 450 is undefined because you're dividing by 0. Even and odd trig functions. You've done even and odd before. An even function was, an even function was f of the opposite of x is equal to f of x. Sorry to stutter there. Whoops. Whoops. This is an odd function. Sine is odd. Let me start over. This is an odd function. I don't know what I was trying to scribble there. I might as well get rid of it. Let's try this again. F of the opposite of x is equal to the opposite of f of x. This is an odd function. This is an even function. Oops, even. Because f of the opposite of x is equal to f of x. So to prove it to you, draw an angle here. How about 30 degrees? Yikes. Oh, I've got my volume turned on here, but okay. 30 degrees. Well, it's funny, it went blank, but it's going red. Huh. It's still going to be blank. Nope, there we go. At 30 degrees, your coordinate is square root of 3 over 2 1/2. And at negative 30 degrees, it's going to be square root of 3 over 2 negative 1/2. If I want the sine of 30 degrees, I get 1/2. Sine of negative 30 degrees, I get negative 1/2. So when you change the sign on the input, if you get the output opposite in sign, it's odd. Changing the sign on the input changes the sign on the output. That's odd. Even, cosine of 30 degrees is square root of 3 over 2. Cosine of negative 30 degrees is also square root of 3 over 2. You changed the sign on the input and got exactly the same output. That's even. Okay? How they're going to try and work with this with you is they're going to say, okay, sine of some angle is a third. Rotate whatever that angle was, but rotate it in the opposite direction. Doesn't mean you're rotating it at negative, because the initial angle could have been negative 42 degrees. All this is saying is rotate the opposite direction. Okay, sine is an odd function. If you rotate the same amount, but in the other way, you're going to change the sign. Whoops, change the sign on the answer. Not just make up a whole new number like I just did. Change the sign on the answer. Okay, cosecant of negative theta then. Cosecant is related to sine. If sine of negative theta is negative a third, then cosecant of theta is negative 3. Okay? So if I ask you, if I give you this, and I ask you that, well, first, find the sign rotating the other way. Take that answer, and because you know cosecant is reciprocal of it, then take the reciprocal. So negative 3. Okay, tangent is also odd, because tangent, and we haven't talked much about this, is sine of theta over cosine theta. So tangent of negative theta is equal to sine of negative theta over cosine negative theta. Well, sine of negative theta, by its definition on the previous page, is negative sine theta. And cosine, the negative just goes away. What is this? That's tangent. So tangent of negative theta is negative tangent theta. So I just proved to you the tangent is odd by using the two definitions we already know. Okay, here you're given some random coordinate. You don't know what the angle is, and you're asked to find the sine. Sine is your y value, so the sine is 4/5. Cosecant then is going to be its reciprocal. Cosine is going to be negative 3/5 because it's your x value. It's your x, so you're just going to read the x out of it. Secant is going to be the reciprocal. Tangent is your y value over your x value. I'm going to pull this thing down so I can see it. Whoops, when I'm doing the work. Tangent is your y over your x, so 4/5 over negative 3/5, which is 4/5 times negative 5/3. The 5's cancel out, so your tangent is negative 4/3. Cotangent is a reciprocal, so it's negative 3/4. Okay. Here's a different example. It doesn't matter that you're sitting down here in this quadrant. If you use the definition of SOHCAHTOA, oh, this is going to be arduous. It's going to be opposite over hypotenuse. Well, where's your hypotenuse? Which, oh, yeah, awful. Don't do it. Oh, you'll be awful. I can't stress that enough. It's just your y value. So what's your y value? Negative 12/13. Done. Cosecant the reciprocal. Okay, negative 13/12. Cosine of this angle? Negative 5/13 because it's your x value. Secant is just a reciprocal of that cosine, so negative 13/5. Tangent is going to be your y over your x, so negative 12/13 is going to be divided by negative 5/13, which becomes negative 12/13 times negative 13/5. So the 13's cancel, and both negatives turn to positive, so it becomes 12/5. Okay, reciprocal, 5/12. And that looks like it's the end of that section.